Alright, so let's go ahead and factor this. So we're going to factor it first. If you like to, you could put check marks. So f of x equals, can I factor the numerator cost? Stays the same. Can you factor the denominator? Yes. GCF of 3, so you have 3 times x minus 2. Can I cancel there? Do you see the same top and bottom? No. So I factored it. I can't cancel anything. And then lastly, I'm going to now set the denominator equal to 0. Now I'm setting the whole thing equal to 0. So I have 3 times quantity x minus 2 equals 0. And remember, the reason why we said we should actually make that not equal to 0 is because we're trying to find values here that make this whole expression there equal to 0, and then that will become undefined, and that's our vertical asymptote. So if I needed to solve this class, do you have to distribute there? No, you could just divide by 3, can't we? What's left? X minus 2 is not equal to 0. And to move that 2 over, you just have to. So I have x is not equal to 2. Okay, let's go ahead and graph it now. So up here it does say find the vertical asymptotes. We found one. Essentially you put 2 in there. 2 minus 2 is 0. 0 times 3 is 0. Anything divided by 0 is undefined, and that's what a vertical asymptote is, right? Let's go ahead and make a sketch. So I'm going to go to my x-axis and mark a vertical dotted line at 2. If you need a visual, you can punch that into your calculator. So I have 2 parentheses 2x plus 1 divided by, remember, use the original 3x minus 6. Zoom 6. And there you can see your vertical asymptote at 2. Let's go ahead and sketch that. Now notice how this function approaches a number above the x-axis, and that'll be Monday's lesson to find that vertical asymptote. So let's go ahead and sketch it. Now on the graph there, it appears it goes above the x-axis. It looks like there's a value at 1. Or maybe a little bit less than 1. A value less than 1. And we've just graphed our rational function with an asymptote at 2.